Hey, this is Helen, and we're working on packet 2.7, which is functions and equations. So, this is paper 1, number 4. It says, let f of x equal 1/2 x squared plus kx plus 8. And so the first question says, find the values of k such that f of x is equal to 0, has 2 equal roots. And so, when they're talking about roots, we should think of the discriminant, which is b squared minus 4ac. And the rules of the discriminant is that when your discriminant is less than 0, that means there are no real roots. And when your discriminant is equal to 0, there is one real root. If it is greater than 0, then there are 2 roots. So they're talking about 2 equal roots, right? So then we know it's plus or minus something, right? And we should know it's also the discriminant should be greater than 0 because there are 2. So then our discriminant is going to be b squared, so our k is b, minus 4a, which is 1/2, c, which is 8. So then it's k squared minus 4 times 1/2 times 8. And you simplify until you get k squared minus 16 is greater than 0 because we want 2 equal roots. So your discriminant should be greater than 0. And so then you just solve for k, and we get k is greater than plus or minus 4. And this is an expression which is totally fine. Okay, so that's the answer for 4a. Now, 4b asks for the probability. So it says each value of k is equally likely for the boundary of -5 and 5, where x can equal either one. And so it says find the probability that f of x is equal to 0, and it has no real roots. So when it says no real roots, it means the discriminant should be less than 0. And I just plug in the numbers within the boundaries of -5 and 5, starting with -5 because it's inclusive. So it's the discriminant again, which is k squared minus 16, should be less than 0 because we're looking for the probability of no real roots, which means your discriminant is less than 0. And so we do that substituting -5 for x, which is k. Sorry, I didn't change the variable, but I substitute -5, and we get 25 minus 16, which is equal to 9. So no, that is not less than 0. And we just do that for -4, -3, -2, -1, 0, 1, 2, 3, 4, and 5. And all the shaded bubbles represent all the discriminants that are less than 0. And so I got 7 over 11 because those are all the possible numbers we can test within the boundary of -5 to 5. And 7 of them, when plugged in, has a discriminant less than 0. So the probability of having no real roots is 7 over 11.